Hi everyone. So today we're going to start the new section on applications of integration, and that's finding volumes of shapes. Okay, so finding volumes of shapes. So I'm going to give you some shape, okay, given in terms of curves and all mathematical expressions, and we need to find what the volume of the shape is going to be. Okay, so we're going to start off with a very simple example just to illustrate the idea, and then we will use that to figure out a formula that we can use. Okay, and this formula will be very general, and it can be used to find the formula for lots of things. Okay, so we're going to start off by imagining a wedding cake. So, you know, like the cartoon style wedding cakes, they're very large and they're made up of a number of layers. Like this. Okay, so we got some sort of cake like this and it's stacked. Okay, so each layer of this cake is some kind of cylinder. It's a very short cylinder with some radius. So this over here is a cylinder. Okay, and then they're stacked on top of each other. So my question to you is, how do we find the volume of this cake? Now, we know the volume of a cube, we know the volume of a pyramid and a cone and a sphere. Okay, all of those simple shapes, there's a formula to find the volume. However, with this like wedding cake kind of shape, there's no formula for this. So there's no formula for the volume. So it's not like we can just plug in the radius and the height and we get the volume of the cake. So we need a different idea to try and work out the volume. So we're going to go back to this idea that the wedding cake is made up of cylinders that are stacked on top of each other. So we do know the volume of a cylinder. Okay, so we know the volume of a cylinder, which means we can work out the volume for each of the layers. So for this first layer, maybe we know the radius and we know the height. If we know the radius of the cylinder and we know the height of the cylinder, we can find the volume. So we can do it individually. We can find the volume of the first layer, the volume of the second layer, and the volume of the third layer. Okay, so we cut it up into pieces, we find each volume, and so the total volume is going to be V1 plus V2 plus V3. Okay, so as we've seen, there's no volume for the whole shape, like we know the volume of a sphere or a cone, but we know the volumes of each pieces of this shape. We can add them together and that gives us the total volume. Okay, so that's the idea we're going to use for other shapes. We're going to take the shape, we're going to cut it into layers like we did with the cake. We're going to find the volume of each layer and then add them all up. Okay, and then that will give us the total volume. Okay, is there anyone that's not following with this idea? Okay, so it's a very simple idea, but we will see that we can use this with quite a lot of applications. Okay, so let's look at the first example. And then while we go through this example, we will try and discover what the formula needs to be. So we need a shape. So let's say we've got a parabola like this, y is equal to x squared. And we cut it off at the top at y is equal to 1. Okay, so we've got the section of a parabola. Now, I want you to imagine taking this parabola, okay, which is like this line, and we rotate it around the y-axis. Okay, so imagine you've got this parabola and we're rotating it around the y-axis. And we're interested in what volume does it make, or what shape does it make? So in 3 dimensions, if we imagine this rotated around, we end up with this cup kind of shape. Okay, sorry, make that a bit neater. Okay, so we end up with this kind of cup shape, and it's solid. Okay, so it's solid all the way through. Okay, so it kind of looks like, like a jelly tot or something, those kind of dome shapes, but it's upside down here. So the side of the shape is a parabola. Okay, so that's the shape we get. But the question is, what is the volume of the shape? Okay, so we've got the shape in terms of a parabola for the sides, and then it's just cut off at the top to make it a solid shape. We want to find the volume. So let's just redraw this nicely. And we're going to use the same idea as this wedding cake scenario. So let's just redraw it neatly. Okay, so we've got this cup sort of shape, and the bottom of the cup makes like a parabola shape. We want to find the volume. So if we go back to this wedding cake picture, we see that we've cut it up into lots of layers, where each layer has some radius and it has some height. So we're going to do exactly the same thing to this cup sort of shape. So at some point, let's just say this point here, we're going to make a slice. Okay, so we've got a slice, a horizontal slice out of the shape. So it's this slice over here has a radius r, and it's got a thickness. Now remember that this is going upwards in the y direction. So I want this thickness to be a very small section in the y direction. Now we know from integrals, remember when we were calculating the area, a very small section along the x direction was dx. That was the width of our rectangles. So the height or the width or thickness, whatever you want to call it, of the slice is going to be dy. Okay, is there anyone confused with that? Why I'm making the thickness dy? Okay, cool. So let's just put in our axes here so we can see what's going on. Okay, so I've got my thickness dy, I've got the radius r. So what is the volume of this piece that I've cut out? The volume is equal to pi r squared dy. That's the volume of this slice. Okay, but what is the radius in terms of our x and y variables? The radius is the distance from the y-axis up to my parabola. That's the radius here. So from the y-axis up to the parabola, that is the radius. And this distance is going to be x. Okay, because I'm going from the axis here, the y-axis, out in the x direction, so the radius is going to be x. Okay, but what is the radius in terms of y? Because look, as I move up my shape, so from the origin moving up, we see that the radius changes in terms of y. So let's just do a little side working here. If y is equal to x squared, okay, that's the shape, then x is equal to root y. So that means the radius is equal to root y. So as I move up the shape from y equals 0 to y equals 1, the radius increases as root y. So that means the volume is going to be pi root y squared dy. So that's the volume of this little section here. Okay, but now again, if I look back at the wedding cake idea, we've got the volume of one layer. So if I want the volume of everything, I need to add all of the layers together. Okay, but over here we have discrete layers. You know, we can count them: 1 layer, 2 layer, 3 layer, and so on. But over here, it's not discrete layers, right? It's a continuum of layers. So instead of a sum, we're going to take the limits of the sum, because the layers are getting really, really small, like the rectangles got really, really small. So the sum becomes an integral. So the total volume will be equal to, it won't be a sum, it will be the limit of a sum, but that's just an integral. So it will be the integral from 0 to 1, because remember the height went from 0 to 1. If we go back to here, so from 0 up to 1. And what are we summing up? We're summing up the volume of each individual layer. And that's given by pi root y squared dy. So this is going to be the integral from 0 to 1, pi y dy. So that will be pi, the integral from 0 to 1, y dy. Okay, that's super easy to do. That's going to be 1/2 y squared from 0 to 1. That's going to be pi over 2. And since we're working with a volume, you can write units cubed if you want to, but I'm not too worried about that. Okay, I'm more worried about the number that you get. Okay, so we see that given some shape, in terms of functions and lines and all of that, just to give us the region, what we need to do is figure out how are we going to slice the shape up. So here, we can see that we can make horizontal slices. So each slice is going to be like a little disc or a little cylinder. So we find the volume of one of these, okay, like we did here, pi times root y squared dy. Then we need to sum all of them up. But remember, we want smaller and smaller discs over here. So the sum needs to be the limit of a sum, or in other words, an integral. And then that's how we get this formula over here. Okay, so this is what we use to calculate the volume. Okay. So that's just the idea that we're going to be using from now on. Okay, the idea of slicing it up into discs and then summing up the individual volumes to get the total volume. Okay, that's quite a bit to start off with. So are there any questions about this method? Yeah, no, we're going to go through lots of examples. Don't worry. I just want you to understand the method. So do you understand why this works and how we use it? Anyone confused with that? Okay, so everyone's okay with this idea. Okay, let's have a look at another example. Okay, someone wants me to go over it again. Okay, so let's do that. So we're given the shape. So let's go here. Sorry. Okay, so we're given the shape y equals x squared. Okay, and we're cutting it off at the top here. Sorry. We're going to cut it off here at y equals 1. Okay, so we've got this section of a parabola. Now, what I want you to imagine is we take this parabola and we rotate it around the y-axis. Okay, so this little area, this region here, we're going to take that region and we're going to rotate it around the y-axis. So what kind of shape do we get if we take this area and we rotate it around the y-axis? We're going to get this kind of cup sort of shape. So it's going to look something like this. Okay. Can you see how the base of this cup has a parabolic shape? Parabolic shape. And we see at the top, it is cut off at y equals 1. Okay. Is there anyone confused with how I got from the parabola shape to this 3D shape over here? Okay, so everyone's okay with this rotation idea. Okay, so we've got our shape. Now we want to find the volume of the shape. So let's just redraw it neatly so we can fill in the bits. Okay, so we've got our parabolic shape. Sorry. Okay, so we've got our shape. We want to find the volume. So in exactly the same way as this wedding cake problem, we're going to take the shape and we're going to slice it into layers. So let's just pick one of the layers to be here. Okay, so we're going to slice it into a layer. So let's just. Okay, so we've got this layer. Okay, so it's like a coin or a disc, something like that. So let's just fill in the X and Y axes so we can see what's going on here. So here's X, here's Y. Sorry. Okay, so the y-axis is going through there. What we want to do is find the volume of this layer. Okay, so if we can find the volume of the single layer, then we can find the volume of all of the layers and then add them together. So this layer over here is a cylinder. It's got a radius and it's got a height. So let's just fold this in here. It's got a radius. Okay, that's an R. And it's got a height. That's what we use to find the volume. So the volume is equal to pi r squared h. Yeah, that's the volume of this layer here. Now, what we want to do is we want to make this layer very, very thin. Like, remember when we found the area under a curve, we made the rectangles very, very thin. So the width of the rectangles became dx. So now the height of this layer is now going to become dy. Okay, so the volume is equal to pi r squared dy. Okay, very thin thickness, or very small thickness. Okay, is there anyone that doesn't understand that step? Okay, so everyone's okay with the thickness here. Okay, so now we need to look at the radius. So this radius here is the distance from the x-axis to the parabola. So from the y-axis to the parabola. That's the radius. Now, what is the radius in terms of x and y? Well, we're going from the y-axis out in the x direction. So that means the radius is equal to x. Okay, is there anyone that doesn't see that? Okay. So we've got here that the volume, let's just carry on here, that the volume is going to be pi x squared dy, because the radius is x. Okay, but this is a problem because we've got x squared and we've got dy. These are two different variables. Okay, we can't have an integral containing x and y. So the integral here is in terms of y because we've got dy. So we need to change x into y. So recall that y is equal to x squared because it's a parabola. It's y equals x squared. That gives us the shape. So we want to solve for x. So you can do this a number of ways. So the radius is equal to x. So the radius is x. So that's going to be equal to root y. So the radius squared is going to be x squared, which is y. Okay, however you want to think about that. So x squared is going to be y. Okay. So you can think of it in terms of the radius, or you can think of it as inverting this to solve for x in terms of y, whatever you want to imagine. Okay. Is there anyone confused with this step? Okay, so we know x squared is equal to y. So that gives us the final step here, so that the volume is equal to pi times y dy. So remember, this was the volume of a single layer. So let's put VL. Okay, so this is the volume of one single layer. What we want to do now is find the total volume, or in other words, we want to sum up all of the layers. So the volume is going to be the sum of all the layers. But remember, when we're taking the limits, the sum becomes an integral. So it's going to be the integral from 0 to 1 pi y dy. Okay, anyone confused with that step? Okay, so now we just do the integral. So this is going to be pi 1/2 y squared from 0 to 1. So that's going to be pi over 2. And if you want to, you can say units cubed because it's a volume. Okay, any more questions on this example? Okay, let's do the next example. So now we're going to be looking at y is equal to x cubed. Okay, similar shape, but a different function. So we've got here, let's just do this in red. So we've got y equals x cubed. It looks something like that. Okay, but we only want to consider the piece from 0 to 1, let's say. So that's this portion over here. Okay, so that's the portion we're going to be considering. From 0 to 1 along y, and then the shape is given by y equals x cubed. And we want to rotate this around the y-axis. Okay, so what kind of shape does this produce? Well, it's going to be very similar to the parabola shape. So it's going to look something like this. Okay, you see, because y equals x cubed has a very similar shape to y equals x squared. So we end up with the same kind of 3D shape here. Okay, so from the curve, we get our 3D shape. Okay, we're going to do exactly the same thing as before. We're going to cut this into layers. So we've got a layer, looks something like this. It's got a thickness dy, and it's got a radius r. But remember, the radius from the y-axis is given by this distance x. That's the radius. So the radius is x. Okay, we'll get to more examples later on where the radius is not x. But for all of these cases, the radius is going to be x. Okay, so what's the volume going to be? The volume is going to be the integral from 0 to 1 pi x squared dy, because the radius is x, so the little volume of the slice will be pi x squared dy. But again, we've got this problem. The integral is in terms of y, but we've got an x variable. That's not going to work. So we need to write this in terms of y. So need to write this in terms of y. Okay, so that it matches up with the integral that we're trying to make. So that's easy to do. We know y is equal to x cubed. Okay, that's given because that's the shape of the of this outside part. So that means y to the 1/3 is equal to x. Okay, everything good so far. So that means y to the 2/3 is equal to x squared. And this is what we need. Okay, so now we can substitute that in terms in place of x squared. So that means the volume is going to be the integral from 0 to 1 pi y to the 2/3 dy. Now everything is fine because it's all in terms of y. Okay, so the integrand is in terms of y, we've got dy, the bounds are in terms of y, everything's good. Okay, so now we can integrate. So the volume is going to be pi times, we add 1 to the exponent, so that makes it 5/3. Divide by that, so that's 3/5. Y to the 5/3 from 0 to 1. So the volume is going to be pi. If I substitute 1, I'm just going to get 1. So that's going to be pi times 3/5. Okay, or we can write this as 3 pi over 5 units cubed. Okay, so this is the volume of the shape. Okay, so you see it looks very similar to the parabolic shape from the previous problem here. So if we had a parabola from 0 to 1, we get pi/2. But if it's now x cubed, so it's a very different kind of shape, but similar, we get a volume of 3 pi/5. Okay, so you see the volume is quite dependent on what curves you use. Okay, any questions about this one?
Sorry, sir. Where did you get x squared?
X squared. That's the radius. So if I just redraw this picture here. Okay, so we've got y is equal to x cubed. Okay, this distance from the y-axis to the shape, this distance is x. So the radius is x. Right? The radius of the shape is given by x. So how do we work out the volume of a cylinder? It's pi r squared dy. So it's going to be pi x squared dy. So the radius becomes x. Okay, like the cylinder. So we imagine this as a cylinder. The radius of the cylinder is given by x. So when we're finding the volume, we need pi r squared. because that's the area of the circle at the top. But r is given by x, so it's going to be pi x squared. Okay, does that answer your question?
Yes, sir. Thank you.
Okay, awesome. Any other questions?
Hello, sir. How do you simplify 2 over 3 into 2 over 5?
I'm just taking the antiderivative. So from here to here, from there to there, I took the antiderivative. So remember the antiderivative rule for powers, we add 1 to the exponent and then divide by the new exponent. So 2 over 3 plus 1, that becomes 5 over 3. And then you divide by 5 over 3, so that becomes 3 over 5. Okay, is that all right? Okay, I'm just using the power rule for antiderivatives. Okay, any other questions? Okay, so I'm just going to leave you with a little homework exercise. Okay, so I will post this on the class WhatsApp group, and then this evening I'll post the solutions. Okay, so you can just have a little practice for today. So we've got the shape here. Okay, let's put it in terms of the XY axes. So we're given y is equal to root x. Okay, and we're going from 0 up to 2. So that gives us this area here. Instead of rotating it around the y-axis, I'm now going to rotate it around the x-axis. Okay, so this gives us a shape like this. Okay, it's around the x-axis here. Okay, so now if we're making our slices, it's going to be something like this. Okay, so the thickness, sorry, let's just draw that a bit neater. So now the thickness is going to be dx. Okay, because we're working along the x direction. Okay, so that's along x. Okay, so I'm going from 0 to 2. The thickness is dx, so that's your hint. That's your hint there. Please find the volume of the shape. Okay, so the outside curve is given by y equals root x, and it's going from x equals 0 to x equals 2. Please find the volume. Okay, and then the solutions will be uploaded this evening sometime. Okay, is there anyone that still has questions about the method that we use? Okay, so is everyone comfortable with drawing the shape, slicing it into layers, and then finding the volume?
Sir,
Yes, yeah.
is there any other method?
Not
This
right.
one,
Not right now. So there are 3 methods depending on the shape. So this is the first one we're going to be using, the method of discs. Then there's washers and shells, but that comes later on with more difficult shapes. Okay, but this is the only way to handle these solid shapes.
okay, sir. Thank you.
Okay. Any other questions? Okay, sure. Let's just go over that bit again. Okay, so the question was, how do we get x squared from here? So remember that we've got over here, the radius is given by x. That's the radius of the shape is x. But what we want is x squared. Okay, so how do we get from x to x squared? Okay, in terms of y. Okay, remember we want it in terms of y. So y is equal to x cubed. This is given as the shape. Okay, that's given to us in the question, y equals x cubed. What we want is x squared, so that we can substitute in here. So we're going to take the cube root on both sides. So cube root of y is x cubed, cube root. So this is going to be y to the 1/3 is equal to x. Because the 3 and the 1/3, they cancel out to give x. So now we're going to square both sides. So y to the 1/3 squared is equal to x squared. We can multiply the 2 inside. So we get y to the 2/3 is equal to x squared. And remember, this was the radius squared, which we needed. Okay, so it's just a bit of exponent work to get from here to here. So that's just some exponent stuff that we did there. Okay, awesome. Okay, someone else had a question? I think someone put their hand up.
So will we ever get a question that requires for us to get an area of let's say a straight line function?
Oh, the area. Yeah, that we covered last week with the area between curves. But all of these questions here are finding the volume. So we don't need to do any area work with this.
Oh, sorry, so I meant the volume of a function that is a straight line. Will ever get a question like that?
Yeah, you could. So we can do something like this. So just roughly, if I do a straight line from like 0 to 2, I can rotate this around the x-axis and I get a cone. So we can do stuff like that. That will come up later on. Okay, but we will cover all of these examples later on. This was just an introduction. Okay, so we will carry on with this tomorrow as well. And please remember that Wednesday, you've got your tutorial quiz on finding the area between curves. Okay, so you got a quiz on tutorial 4. Okay, so please remember that for Wednesday. Okay, but I'll see you guys tomorrow.